Okay, we're going to lecture on our last two sections. These two sections are for dma080. First, I'm going to talk about sections 6 and 7. 6 is radical equations and problem solving. Section 7 is going to be imaginary numbers. Okay, so what's going to happen is when we have a radical equation, let's say we have the cubed root of x is equal to 5. If we happen to have this problem that we're trying to solve, all that we really have to do, the basis of solving radical equations, is to eliminate the radical by raising both sides of the equation to the power that's equal to the index of a radical. So in other words, if you have a base raised to a power, and if the index is the same for that power, this whole unit becomes just the letter A. It comes out. So if you have an index and the power, hang on, I put it in the wrong place. If you have the index, and if the index is your exponent, it, in other words, removes the radical sign. So in this sample problem, if the index is 3, if it's the cubed root of x, in order to get rid of the radical, I just raise this side to the cubed root. What we do to one side of the equation, we have to do to the other. So that means I also need to cube the right side. So all of this now means the x just comes out from under the radical. And then on this side, you would have 5 to the third power, which would give us 125. Let's say if we had the fourth root of m is equal to 2. The power that we would raise to would be the same as the index. So I would take this whole unit and raise it to the power of 4, which means on the other side I would raise to the power of 4. So on the left, the m now comes out from under the radical, and on the right side, 2 times 2 is 4, times 2 is 8, times 2 is 16. That will give us a solution of 16. So that's technically what we're going to be doing as we work with solving a radical equation. Okay? So let's say we happen to have the square root of 3x minus 2 is equal to 4. So what we want to do is we need to take this radical, determine the index. There's no number, so it's understood to be a 2. So if I raise this to the second power and this to the second power, the left side now comes out from under the radical, so no radical exists anymore. 4 squared, 4 times 4, would give us 16. At this point, all we have to do now is just simply solve for x. So I'm going to move my 2 over, and I have 3x is equal to 18. And then we divide both sides by 3, and x would be equal to 6. If I took the number 6 and I plugged it back in, 3 times 6 would give me 18. 18 minus 2 would be 16, and the square root of 16 is equal to 4. So once you do this, you would plug in the value that you get to be sure that it is correct. Okay, let's try another. Let's say we have the cubed root of x minus 1 minus 2 equals 2. So in this equation, what we're looking at is we happen to see that here's our radical, but there's still also something else here. Before I can cube this side, I need to move that 2 to the other side. I don't want to use the radical until I've moved it over. So now I've got the cubed root of x minus 1 is equal to 2 plus 2 is 4. Now at this time that the radical is isolated alone, I can raise this to the power of 3. On the left side, the x minus 1 now comes out. 4 to the third power will give us 64. And then in my last step, I'm going to move my 1 to the other side, and my x is equal to 65. If I plug 65 in this equation, 65 minus 1 is 64, and the cube root of 64 is going to give me the value of 2. So that does check to give me a correct answer. Now, for this particular problem, the square root of 2y plus 3 equals -4. For this one, they always give you a little hint on this, and they tell you to work smart, not hard. They're giving you a hint here, and I believe even on the test, you do have one actually like this. If you recall earlier on, if you have the square root of something, can you have a negative answer? Is it possible? So if I have the square root of 25, my only possible answer is going to be a positive 5. It cannot be a negative 5. There can be no negative answer with an even index. So if the index here is squared to the 4th, the 6th, the 8th, anything that's even, we can't have a negative answer. So when I look at this particular problem, what do you think our solution is going to be? It's going to be you can't have a negative answer. So for this particular problem, we would not be able to do so. So we can just simply, I believe the choice they give you in the workbook is they give you a choice that says no solution, because you can't have a negative answer for that. I do want to give you another type of a problem solving that you're going to have. You will be given a couple of questions on the test where you'll be given an actual formula that you would be using. Bear with me one second. Let me grab where I have that written down at. I think I'm moving my paper, so give me a moment. Okay, here's the equation that you have. You have a problem where they give you a formula. They give you the letter S. They give you 2 times the square root of I, and then they give you a -9. In psychology, it's been suggested that the number of S nonsense syllables that a person can repeat consecutively depends on his or her IQ, the letter I, according to this equation. If the person can repeat 11 nonsense syllables, find his IQ. So in this case, if S equals 11, we are going to solve for the I. So what that means is where the S is, we're going to substitute our 11. When you're looking at this problem, think about treating this whole unit as being the variable. The first thing is we need to get this alone, so we're going to take this 9 and we're going to move it to the other side of the equation. 11 and 9 is going to give us 20, and then we have 2 square root I. We're trying to get to the I. So we need to now divide by 2 on both sides. 10 would be equal to the square root of I. And in order to get I alone, we're going to apply what we just learned. It's a square root, so if I raise it to the second power, the I comes out. That also means I take the 10 and I square the 10. When I square the 10, 10 times 10 would give me a 100. Okay? So that's all that we're actually doing in this part as we're working with section 6. In section 7, we are looking at imaginary numbers. With imaginary numbers, what happens is if we have a square root with a -1, we are going to use a lowercase letter I to represent the square root of -1. In other words, if we have, let's say, the square root of 81 times the square root of -1, we know the square root of 81 is a 9, and the square root of -1, I just told you, would be the letter I. So that, in other words, would be our solution. Let's say we have something that looks like this: the square root of -70 over the square root of 7. I can put both of these, -70 over 7, under the radical. I can simplify 70 divided by 7, and that gives me a -10. Now, in this case, I can't factor the 10. It's not a perfect square root, but I can separate it as -1 times 10. So what's going to come out is that -1 is going to come out as being an I, and then I still have the square root of 10 that's going to be left up underneath the radical. Now, let me show you here on the calculator. As we move into solving problems, the viewing examples have everything longhand. You do not have to do these longhand. You may use your calculator, and if you look here, if I press the second and then I come down to the bottom to the decimal, that gives me the value I. So when you are using your calculator, you're just going to do second and then the I, the decimal key, and that'll give you that particular variable that we would need. So let me give us a couple of problems here. So if we have, let me give us an addition and a subtraction. Here's our addition problem. If we have 2 plus 7i plus 9 minus 6i. Okay, so we're going to go to our calculator and we're going to key that in. And we're going to use parentheses just as we see them. 2 plus 7i plus 9 minus 6i. Just check and make sure you have it typed correctly. And when we press enter, we can get our final solution of 11 plus I. Okay, let's do a subtraction. 6 plus 7i minus -1 minus I. Okay, so we're going to come back to our calculator. We're going to key this in. 6 plus 7i minus -1. Whoop, forgot the parenthesis. Hang on. -1 minus I. And when we enter, that's going to give us 7 plus 8i. Okay, let's do a multiplication. -2i times -5i. -2i times -5i. That gives us the number -10. If we happen to have two binomials, usually we would have FOILed this, and if you do this longhand, you would FOIL this, but we can simply key it in as we have here. 4 plus 5i, and then we have 4 minus 5i, and that gives us the whole number 41. The only real point you have to pay attention to is when we get to a division problem. So let me write down two division problems that we're going to do. When you do a division problem, if you do not type in a parenthesis around the numerator and denominator, you'll get an inaccurate answer. So when we do these, we want to be sure we put a parenthesis around the numerator, a parenthesis around the denominator, and then we do division in between the two. And again, a parenthesis here. Even though this looks like one term, if you don't use the parenthesis, and if you type it in both ways, with and without the parenthesis, you'll see that you get a different answer each way you type it in. So I'm just letting you know the correct answer is going to be the answer when you do type in the parenthesis. Okay, so here we're starting with 7 divided by 4 plus 2i. That's our first one. Oh, now this looks peculiar. And they're going to tell you that they want the answer in the form of a fraction. So all we have to do, just like we learned in DMA20, to change a decimal to a fraction, press math and enter 2 times, and then you're going to get 7/5 minus 7/10 I. 7/10 minus 7/5 I. So that's all you have to pay attention to if they give you the answer in the form. Oh, wait a minute, I wrote it backwards, didn't I? Oops, let me correct that. So that one is the 5. Apologize. And that one's the 10. Okay, so let's look at our last one on the calculator. So we have negative 25 plus 15i divided by 5i. And we get 3 plus 5i. And I just want you to see that the answers are different. Let me key that again. And this way that I'm keying it is inaccurate. I'm going to use the parenthesis with the numerator, but if I leave it off in the denominator, I want you to notice I get a different answer. Notice the signs are different, and that makes it completely incorrect. So you have to remember to use the parentheses when you have those division problems. Okay? And that's all that we have for those two sections.